So we're going to go ahead and try a final example on page 124. This one's going to be a trig one, so don't get too worried about it. Okay, it still works the same way as the other examples where we have to find the critical points and make that sign chart. It's just that this one involves trig, so we may have to use the unit circle to help us with that. So if you want to take a look at page 10 from your notes when we filled this out earlier this year, it might be beneficial for this problem. So what we're going to try to do for this equation is figure out where it's increasing, decreasing, and has a potential max or min. And this time we're only looking on the interval from 0 to 2 pi. So if we were to just do one cycle or one period, okay, not a domain of all real numbers, because if you think about a sine graph is a wave, so it should really have infinite amounts of maxes and mins. So we're really going to have just a shortened version or shortened domain from 0 to 2 pi. So let's first figure out what our derivative is using our shortcuts. Again, if you do not like the thetas in there, you can just rewrite them as x's and think about it in that way. It should work very similarly. So I'll kind of write it out with x's if that helps you. So we first want to figure out what's the derivative of x or theta in either case, and that would just be 1. And then we want to add the derivative of 2 sine. Well, the shortcut derivative for sine is cosine, and we're essentially just multiplying that by 2, so this would be 2 cosine of theta, or x, whatever variable you're using. So let's set the derivative equal to 0, and we'll try to solve for the variable. We can subtract 1, divide the 2, right? So on our unit circle, we got to find the angle locations where the cosine value is -1/2. So if you look at your unit circle, cosine is the x-coordinate. -1/2 would be at 2 pi over 3, and also 4 pi over 3. So we actually have two solutions. So these are our critical points. These are potential max and mins, but we need to use a sign chart in order to determine is it actually a max, actually a min, or maybe it's a level location like we saw in the last example. So our domain is 0 to 2 pi. And we'll go in order with the critical points. And we're going to pick a number within the interval, and we're going to plug it into the derivative to see if it's positive or negative. So pick any angle you want between 0 and 2 pi over 3. So it'd be basically any of these in the first quadrant on your unit circle. And if we were to plug in that angle into our derivative, notice how we're looking at the cosine value. So all these cosine values are positive, okay, sometimes 0. So if you were to take 1 plus 2 times something positive, or 0 if you chose that top angle, notice how your result would still be positive. So we'll go ahead and leave that in there. Next we want to pick something between 2 pi over 3 and 4 pi over 3. So that would be kind of in this section of your unit circle. And notice how all the cosine values would be negative. So we have 1 plus 2 times something negative. Now you might actually have to calculate the value of this negative result to see how it compares to 1, because that can be a little tricky if it remains positive or remains negative. So maybe we'll just pick one as an example. I think pi would kind of be an easy one, because notice how the cosine value is -1. So 2 times -1 would be -2, and if we add 1, that would be -1. So overall our result would be negative. Our last interval from 4 pi over 3 to 2 pi, so we're going to be in this section of the unit circle. Notice how the cosine values are positive, so 1 plus 2 times something positive is still going to be positive. Okay, so unit circle analysis might come in handy for that sign chart. So if this is the result from the derivative, we now know what the original function was doing on these intervals. Increasing, decreasing, increasing. We have some sign changes, so we can classify those appropriately as a max for the first one and a min for the second. So we don't really have a level spot for this particular graph like we did in the last example. Let's go ahead and write our justifications. So f of theta is increasing on 0 to 2 pi over 3 and 4 pi over 3 to 2 pi because the derivative is positive. And similarly, f of theta is decreasing on 2 pi over 3 to 4 pi over 3 because the derivative is negative. Alright, so then let's go ahead and tackle our maxes or mins. So f of theta has a max at theta value of 2 pi over 3 because the derivative was 0 and changes positive to negative. Alright, now let's actually find the value. So if we were to plug in 2 pi over 3 into the original function, we want to see what we would get out. So our original function's at the top. 2 pi over 3 into theta would just leave that for the first one. And then we want to add 2 plus sine of 2 pi over 3. So let's go ahead and go to that angle location. 2 pi over 3 is right here. The sine value is square root of 3 over 2. So we can go ahead and substitute that in. So it looks like we're left with 2 pi over 3 for the first term, and then we're going to add the square root of 3 since the 2's would cancel. So you can leave your answer like that. I know it looks a little weird, but this is still representing a maximum height on your graph. Let's go ahead and try the minimum. So f of theta has a min at the theta value of 4 pi over 3 because the derivative was 0 and changes negative to positive. Let's go ahead and find that actual ordered pair on the graph. So we'll plug in 4 pi over 3 into the original. We'll get 4 pi over 3 plus 2 times sine of 4 pi over 3. Unit circle, going in that spot. It looks like we have negative square root of 3 over 2 as the sine value. So we have 4 pi over 3 minus, because the 2's are going to cancel, that square root of 3.